get going. So we didn't, I figure I still want to make sure we get through a review of all the JavaScript content. So what we're going to basically cover today is finishing reviewing JavaScript fundamentals. And then for homework for the next class, I'm going to have you guys really try and focus on picking up HTML and CSS so that unlike these first few classes, all of the next class, it'll be more of, they'll be talking, but not so much like just instructing, more questions and hands-on stuff. So I'll be sending out just shortly after class is to have you guys work through homework for the next one. I'm going to send out this free code camp link, and I'll try and get it as close as I can to, you know, this being the actual thing I try and link to, but I'm going to try and ask you to work through, and I'll give a target here, let me find it, about half of this content in their HTML and CSS section. Mostly like covering more of the HTML side, but there'll be some CSS in there. If you want to work through more, you can work the rest of it and just get a really strong feel for that. And then next class, we'll have a more sort of a short introduction to HTML and CSS and overview of it so that, you know, you have a little bit of that presentation, but then talking through what you know, had problems with or what there were challenges for as you work through that, any questions you have about how CSS work and stuff like that, because that'll be a lot of the underpinnings of apps. We'll use a syntax that's just like HTML, just a little bit of other stuff built on top of it. So we'll need to have a sort of strong foundation for that. But for this class, mostly, like I said, more JavaScript review. You know, if you guys have questions about anything that we go through, just ask them, and I'll try and explain them in a different way or talk about them with different language. Some of this will be maybe just slightly new, but none of it, the topics themselves shouldn't be new to anybody. We may just be covering new ways to do things or very slight variations from what we've done before. Last time, I believe we finished covering conditionals. Maybe we didn't. Conditionals, which are pretty simple. The idea for a conditional is just being able to check one thing and then otherwise take another action. They're a pretty fundamental building block of being able to work with any programming language or being able to code anything. You need to be able to know like when you should take one action versus another. And inside of the condition block, like for example, inside of the if, you're just creating a statement that evaluates to true or false or truthy or falsy so that it knows which path to take when you're writing that conditional. And you can also build for like if else. You don't have to have just if else. You can have if, else if, as many extra conditions as you need. Are there any questions on just simple if else structure? I feel like that was something we did a fair bit with. So one other case, and I don't think we ever really covered this, but you'll probably encounter it in some of the other languages, is there's that sort of if, else if, else if, else if can get a little busy when you have a lot of conditions to check. So there's a shorthand way to write out stuff like that where you don't have to write it out. That's known as the switch case conditional, but you can think of it as just a simplification of if, else if, else if, else if, else. And when you're doing a switch case conditional, the way you write them out is switch is just telling it I'm entering this switch case and here's what I'm switching on, the variable or the thing that changes. And then here's the case I want to execute in these different situations. So if you were to have, I don't know what to go with here. Let's see, var. Let's do fruit. Let's stick with their example, and we'll create an array of some different fruit. Let me quote that. Persimmon's a fruit, right? Is persimmon a fruit? I think it is. What?
I don't really know.
Oh, no, it's not?
It is.
Okay. Somebody says it is. I got validation. I'm done.
What about tomato?
Oh, that's tough.
No.
Oh, we'll add it in. So if we were, we could write a case statement that really cared about just about any portion of this or a switch case. But let's say in this situation, we want to have spit out all the ones that have, I don't know, we're going to call it a short name. And so short, like in one case, it'll be ones that are short or really short and then medium length and then long or something, right? So we could write that as an if else if we were doing that. So we could say if, we could iterate through our fruit or something. And if the, whatever this given fruit was, so we can assign this, let's say, call this fruits. I'm going to do that, in fact. Fruits equals fruit. So let me just make sure that worked. Now I can reassign fruits to any of them in it. Fruits, we'll grab the first one, right? We could write like a conditional here. We could say if fruit.length is less than, I don't know, 6, then say something, right? Console.log, easy name. And we could have a else if fruit.length is less than 7. You can say like console.log. Somewhat harder. Right, like, okay, these are ones with really long names. Console.log. Let me turn this off. There we go. No. And it'll, we could have that condition that way. But if you're comparing against these, or that's a little hard, very verbose to write out. There's a lot going on in there. So if you wanted to instead write that same thing using a sort of switch case statement, you could write it like this, where you do switch on length. And we could put this all inside of a loop if we wanted to do this for each one of these. Now we can write our cases out. Case, actually, I don't know if I can do that. So I just need to compare it against an actual value. You could only compare it, I think, against a real value. I don't think I can say less than. Like I got myself in a conundrum. Console.log, short name, right? And you have to have cases for each one of them. So I don't know exactly how to compare it against something here. But I think you would get the general idea. So we could say case 6, console.log, longer name. And then when you're working with this, a lot like the else statement in a if else, you'll have a default. And default is saying I didn't deal with this in one of my cases. So call back to this. I don't know. I forgot to put breaks as well, I think. I totally screwed up the syntax for this guy. So it's going to throw a tantrum at me for the way that I wrote this. Let's do it this way instead. We're gonna change our switch, and we're just gonna do it off of fruit. We're gonna say case And then we'll put something in here, some information. Console.log. Most popular fruit in America. You know, random facts. For orange, you could say console.log. Chock full of vitamin C. Right? And we could write out some additional ones. Oh, I keep forgetting to put my breaks in these. That's probably what's causing the problem. Which is a mistake I would make, and I'll explain that in just a minute. Default console.log. No facts for this fruit. Here, but I will. And then since fruit had orange, these sort of chock full of vitamin C, right?
You can put your statement on case. So like less than. You can use something in the case. I don't know if I'm explaining myself.
I'd have to look it up. Yeah. I'm sure there's some mechanism to do it. I just off the top of my head didn't know how to write it in this because I didn't assign it to a variable of some kind to compare it to. But are there any questions on just the switch case statement? The break portion that I was mentioning there is that what you need to do is at the end of each case, you need to have this break statement. Because that tells it, don't look at other cases. That's the one thing that's different between a switch case and an if-else, or an if-else, if-else, if. Is in a switch case, it will keep running the code even after the statement that you're on, if there's any other code to run. So let me try and write a very simple one here. Switch, let's say like for case, this will have the problem I'm looking for. Console.log for not certain, but I think it will. Default nothing. What you notice is that both 4 and 5 were printed out. But that's because once it's matched that case, it'll run that code, but it'll keep running after that if you don't have a break statement. So it'll execute the code inside of the other blocks as well. So once you've matched a case, you need to tell it break out of this whole thing or else it'll continue running the rest of that code. It's a little confusing. It's something that will probably trip you up, but a simple check on the syntax online should clarify that.
So what if you're doing more like conditionals, like you were if you're doing like a loop, like for every shoe that's a pair, I guess, just print out this or something.
Yeah, what you'll find is that it really depends on what you're trying to solve when you're doing this as to which approach you'll take. Almost always, if you're just doing like this or that, you'll just do some sort of basic if-else block. And a lot of times if you add just in a third thing or something like that, you might be like if, else. Now, if you have the switch and case statements tend to be used when it's you have a very known set of inputs and they map to very specific structure on the output. So it might be something like fruit backs is an example. Like, oh, if I have this fruit, give this back, give this back, give this back. And it tends to also be something where you have that more than like 2 or 3 cases. Like the switch case is like, oh, I've got 7 different things. I know what each one of them is going to be in the exact route that I want each one to go down. Sorts of examples where you're really going to. more than
For,
anything
like,
else.
pretty much predetermined functions, I guess, or like you were saying, you would use like a switch.
Sort of paths where you know you're really switching to some different paths in a very specific way for a lot of different inputs. So a lot of times you're using it with very structured versus something that's more loose input from the end user. Any other questions on that? So let's dig into looping. In class, we talked mostly about the while loop, which I think we mentioned here. And that was the loop structure I had you guys use because I was trying to keep it very simple, right? I didn't want to introduce a lot of complexity, and I feel like the while loop is the easiest one to pick up at first. So this code here should look very similar. Var I equals 0, while I is less than array dot length. Log. Okay. We wrote that code several times, whether it was to spit out fruits, to a lot of different variations of that. Probably, however, the most popular looping structure that you'll encounter in other code, while loop, but the for loop. And part of the just combines all the different pieces of your condition in one place. So you get to think about your loop structure separate from the logic and the body of it. And I think I did introduce this, but just sort of briefly. So for a while loop, remember every loop that you have has an initialization step in it, your condition that you're checking against, and your changing of your condition so that you'll eventually get out of your loop. And that's, in the while loop, the initialization comes outside of the loop itself, like right here. And then when you check your condition, that's inside of this sort of block of this section of the while loop, the parentheses here, but you have to remember to change your condition you're checking against at the bottom or somewhere in your while loop. So you sort of spread that logic out into a whole bunch of different places. Is you bring those three pieces that are all related to the loop into one place in the code so that you can think about them and then think about the logic of your code. So if we have our fruits array, and we wanted to iterate over each item in it with a for loop instead of a while loop, instead of having to first initialize everything, we can just write our for loop right here for var I equals 0. That's our initialization. So if you looked at your while loop that we've written before, var I equals 0, well, we're just putting that sort of inline in our for loop block here. Then we have that condition, I is less than fruits.length. That's the same as what's inside of our body of our while loop. And now we need to change our condition so that we will change it so that we'll eventually exit out. So inside of this little bit of a for loop, we were able to encapsulate all of the logic that got spread out in the while loop before. And now we don't have to think about it when we're writing the body, and really all we care about is what do we want to do with our current fruit, right? Console.log fruits. I just want to write it out to the console. And that'll just iterate through them and sort of encapsulate that bit of logic all in one place. Does that make sense? Why like a for loop could be really nice in terms of separating out the things that you're thinking about in code. So I'm just thinking about the looping structure, and then I'm just thinking about what I want to do inside of. Now, there's one other, I don't think it's even mentioned in here, for loops very, very heavily when we're working with React code, and that's the for each. And for each also simplifies some of the logic around trying to think through this to deal with each item in the array. Make sure that this works. Ignore this for a moment. You don't need to know the details of what I'm writing. Okay. So For each is a very popular pattern with React, and the way this works is, I'd say in a lot of modern JavaScript it's pretty popular. The way this works is instead of having to write out your looping structure separate and even having to really care about what you're doing, if you're just iterating over something, like in this case, we're iterating over each item in the array. Well, modern JavaScript has added a method onto arrays called for each, right? Sort of makes sense. I want to do something for each item in my array. And then instead of having to write out all of this logic, which is really just saying for each, we collapsed it here. And you don't need to worry too much about this syntax right now. We'll cover this in a little while. But this is just a function. And what happens is for each item in the array, it calls this function that's the argument to it and passes that item into it. So if I want to make this easier to read so that it looks closer to other function calls that you've seen, I might do something like this. Var output equals, and so I'll actually just, again, ignore the exact syntax of this for the time being, but we'll definitely go over it more. And now I could rewrite this fruits.for each and just say output fruit. That line there looks a little simpler at first. Okay, I've just passed in a parameter, and for each, I did something with this parameter that I passed in. So that makes it look more like a function call that you might be comfortable with. And then the interesting part about it is all we did was pass in a function to it, each item in it. And you don't have to understand all of the details of how that works right now and all the details of passing in a function as a parameter. We're going to do that again and again and again, so you'll get comfortable with it just through repetition, most likely. But are there any questions about that other than?
You just do it.
Without using the arrow function? Yeah. So if instead we did it with it, let's do a function statement. I'll call this one print fruit. So we're used to function statements, right? This is more of how we wrote our functions. Function, the name of our function, and now console.log fruit. So we've got a simple print fruit function that exists. We can see it tells us it's a function. And now if we go back up to where we called fruits.for each, we could use just print fruit instead of the output fruit that we had before. Same thing. It's just calling that function for each item in that array and passing in that item as the argument. Like I said, we'll definitely be doing this a lot more. So if you have further questions about sort of passing a function in as a parameter, you probably get it down more just through repetition than you will trying to completely understand it the first time that you encounter it as a problem. Any questions about that? Is it who's having a little bit of a hard time wrapping their head around the idea of passing in a function like that and having it work? Okay, yeah, that's perfectly fine. Like I said, I'll probably be doing this a good deal more, and then feel free to ask questions as we encounter them, or I'll try and explain them in different ways, or maybe even try and whiteboard something out later to go over it again. Sort of for each approach, you'll see that a lot in code examples. So it's something I wanted to introduce you to because you probably won't see someone write out the for loop most of the React stuff, because usually it's iterating over the items in an array. And this is, in a sense, an even easier way to do that. Well, functions. We just talked about them a little bit. Who remembers how to work with functions and from our last class. A little bit. So a function is just, remember, it's just about the same thing as a mathematical function, at least at the most basic level. It's something that takes in some parameters. It's a little block of code, parameters, and does something, and then can return a value. Like their example, the easiest, like most basic one is just add, right? So you can have add. What are the things called? And the numerators? What are they called? I can't remember. They just call them param, but arg1 and arg2. And so when you're writing a function, the function declaration model, the way that you do it is you say function first, and then you give the name of your function. And these are your arguments to your function. And then inside of your body of your function that you're writing out, you can really sort of do whatever you want, but usually you're working on doing something with those arguments and then probably returning a value. In this case, we want to return arg1 plus arg2, so the sum of them. So now we have an add function that we wrote, and we can call it with any arguments. And it'll return the value from each one of those calls, right? We defined it having 2 parameters. So that's how many we're going to call it with. Because if we call it with less than that or more than that, the behavior will be sort of undefined. So here we got not a number when we called add 5. And that's because we didn't pass in that second argument. In just a minute, we'll look at what actually happened inside of the function when we did that. But it came back with not a number. And if we pass in more, I'm sure what's going to happen when you say add 4, 5, and 6, and you get back 9, so it looks like it didn't do something with all of them, right?
Yeah, what if you would done like just add a colon after the argument 2? Would it have put it in 6 too, or would it still full of 9?
Well, you can work with a variable number of arguments in just a minute.
Okay.
With functions. So the number of arguments, this is a good thing to jot down because you'll probably hear it said a lot, but the number of arguments that a function takes is known as the arity of the function, A-R-I-T-Y. So that's just a term for like how many arguments does it take when you call it. And you'll see that in just a minute as well as we keep going through here.
So on that last example, it only takes the first 2 and it doesn't care about the third one. It skips it.
Oh, you can see when we defined add, we said argument 1 and argument 2, and we assigned those variable names or those arguments to the parameters that were passed in, right? And so those are the only ones that it actually knows what to do with here, because this third one, you'll see that it actually gets passed in a minute, but we didn't tell it what to do with it, so it doesn't know to do anything.
In memory, does it just dumps it, or?
We'll get to that in just a second. Yeah. So are people sort of okay at least with this function syntax, the way you can define it using function and then the name of your function and the arguments? Whenever you want to return a value from any function, return is how you return values from them. So the other way you can define them, at least in this older style, this ES5 style, is you can assign them using variable assignment, where you're doing a function expression. And the syntax with this is a little different. So if instead now we wanted to create an add function this way, you can assign it directly into a variable. And instead of naming it, you could just say function arg1, arg2, and then return arg1 plus arg2. And if we look at add, it tells us once again, oh, this is a function. It's able to look at that and see that it's a function. And if we pass in parameters, we get stuff back in sort of the exact same way. Little that's blatantly different between the two implementations or the ways that we did it. I think I'm probably going to get this wrong. That worked. Interesting. Let me try something here. Interesting. So you can even actually, I wasn't sure if that was going to work. You can get the name of your function. I thought in this case it might tell us that it didn't have a name because we just assigned it to a variable, but it did still come back telling us that the name was sort of that variable or whatever. So that's just another syntax for writing functions. And then I don't think this is a really good example for him to have provided. It's sort of confusing. It's close to what I wrote for you guys earlier, right? This was him declaring a function directly in some other function and having it passed in as an argument. So you can just pass a function in like this, which is, like I said, close to what I did with that for each example earlier. I just used a little bit different syntax for it. About these two different ways of writing functions, the syntax around them or anything like that?
Function.
One is function function declaration,
Function declaration.
and the other one's known as a function expression. Yeah. And you probably won't. I mean, you can work to memorize that because there are places where people will refer to that, but you know, you can also always just refer to what's the difference between the two for that. I'm sort of gonna skip over this. We may encounter it later, but I don't want to get into it too much because it's a little bit of a confusing idea. Function declarations are hoisted. It's more about how JavaScript works inside of a file, and that you can call a function before it's been declared, or you can at least refer to it before it's been declared. But if there's some complexity around that, if you guys have a problem with it or we encounter something where we need to cover it later, I'll cover it in more detail. But right now, I think it's better to gloss over it and not really cover exactly how that behaves. So let's come back to passing in variable number of arguments. One thing that distinguishes JavaScript from other languages is the number of arguments. In some languages, if you have an add function and it takes 2 arguments, and you have an add function and it takes 3 arguments, those are 2 distinctly different functions because the number of arguments or the arity of it is part of the signature of the function. So you could create sort of both of them in a sense. And as you pass in the right number of arguments, it'll know which one to call. Arguments is not part of the function that way, and part of the flexibility that provides is you could actually pass in a variable number of arguments as we were doing sort of before, and inside of every function a special variable gets created which is just called, and that contains, that's essentially an array. It's not quite an array, but it looks like one, of all of your arguments that were passed into your function. So we can go back, and I'm going to rewrite this add, or actually I'm just going to write a new function. Function print args. And I'm not going to give it any explicit arguments. And then inside of it, I will do a for loop. I is less than arguments.length. So you'll notice I didn't define any parameters to my function. So it shouldn't expect anything explicitly, but I still have access to anything that somebody does pass into it off of this built-in arguments. So I can call print args 5 and 4 and 6. And inside of it, when it gets called, it says, oh, I have 3 arguments. Arguments.length is 3, and then it runs that for loop and steps over, and you have access to each one of those arguments while you're inside of that function. So you have access to every argument off of this generic arguments variable. And that way you could have a function that took a variable number of arguments if you wanted to build something a little more complex. So if somebody wants a good exercise, I won't assign it as something for everyone to work on, but a good exercise would be to write a add that can take as many arguments as you pass in and will return the sum of all of those arguments. So it'll look a lot like this. But that's a road assignment to practice, because just take as many arguments as I want to pass in and return the sum of them instead of only taking 2. Does that make sense? This arguments special variable inside of a function. One thing that's dangerous about it, I mentioned before, and we'll talk about it a little more, is it's not quite an array. We'll cover some of the differences between it in just a minute. So then what happens, like for example, in our add function that we had earlier, what actually happened when I passed in too few arguments to it? This is their little function that sort of helps show what's going on. And maybe I'll just cut and paste it if I can, to save me from having to type that one out. Cool. So all this function is going to do is it expects 2 arguments. It has 2 parameters defined, x and y. And then it logs them out and returns an array of the arguments that were passed in. Now, if we call f with here a, b, and c, return 2 array. Oh, we have to define 2 array. Ugh. All right. Today, it's right down here. Let me steal it. Let me steal it, and then I can rerun this. All right. This should work now. So what you see is I passed in A, B, and C. And then because the function had a console.log of x and y, we see both of those. But when we converted our arguments to an array, we get back all 3 of them, right? Because it had access to all 3 of those arguments. But if instead now we call it with just A, which means it's going to be short an argument, what it logs is A and undefined. So any argument that it expects that you didn't actually pass in gets defined. And then when it creates the array of all the arguments, all that has is A, because that variable doesn't care. There's no expectation of an argument there, right? So now let's go back to our add function. When we called it with just 1 argument, like add 5, equivalent of what is it trying to do inside of the code there? 5 plus undefined, which gives us not a number. So now we can understand why we got not a number when we called it with just 1 argument before, because the second argument, it gave the value of undefined, and when you add undefined to something else, that's not a number. Does that make sense? Yeah?
Are there any cases where, I don't know, maybe if there's an input and you're expecting 2, but if, let's say, the user only puts 1, convert undefined to 0?
So you walk right into the next section in the book. Especially in 5 JavaScript, right? There's a new pattern for this in ES6, which I will also show you, even though you may not use it as much, but there is a very common pattern that existed, which is if somebody doesn't pass in another argument, what do I do? And let's rewrite our add using this new style. So let's say add arg1 and arg2. Because the style is a little bit of a trick going on here, right? Remember I told you that there's or and these sort of bitwise comparisons, they short circuit. So if something qualifies, if something matches the expression, like on an or, if the first part is true or truthy, then it doesn't even evaluate the second portion. And it returns, in a sense, the value of whatever is true or false, right? So a little shorthand way that a lot of people would assign default values would be this type of, where what this will do is if somebody passed in a value for X, let's say they passed in 5, then this will say 5. Well, 5 is truthy, so it's just going to return 5. So X equals 5. But if they didn't pass in a value for it, then this will be undefined. And undefined is falsy, so it's going to evaluate the next portion and return that, which is 0, and assign that into X.
But that 0 is falsy.
It is, but it doesn't matter because it'll return the last item in the thing that it evaluates. It actually returns that second item still. So it's sort of a shorthand notation for this. So the way you could do that in ours is the same thing, right? arg1. So essentially it's saying like if arg1 exists, then to arg1, otherwise give it 0, and we could do the same thing for arg2. arg2 or 0. And now we can return arg1 plus arg2 and know that even if they don't pass in a second parameter, so if we do 5 and 6, this should work. And if we do add 5, we'll get back just 5. This is a little bit tricky. The first time I encountered this in any programming language, I think it was C++ for me, somebody was writing code like this, and I didn't understand it, just so you know. It was not something that was easy to instantly understand what was going on and why stuff works this way. And I feel like once you can understand the real reason why stuff works this way, you've got a much more solid understanding of programming. So at first, it's one of those things that you just sort of learn to do by rote. You just repeat it, just copy it, because it's a useful pattern. And then later, you'll begin to understand why it works. And that can be sort of a moment, an aha moment for you. I think I understand why this works the way it does now. I feel, like I'm really beginning to understand this language. Are there any questions about that? Now I'm going to show you the much easier way to do a default assignment. This is ES6, so this isn't supported in everything, only newer browsers. I hope my version of Node supports it on my Mac. I hope it does. We'll see. So let's rewrite this again. Function add, and we'll do arg1 equals 0, arg2 equals 0. This is something that's new in ES6. It's called default values. And what it's saying is, if arg1 doesn't have a value, if it's undefined, it's 0. And if this one doesn't have a value, it's 0. So then we can just do return arg1 plus arg2 again. and we should work. We should work even if we pass in nothing, or if we pass in one number, or if we pass in 2, because it's doing a default assignment up there. So that's a lot easier to read, a lot easier to understand, and it sort of removes that extra logic inside of your function body. You don't have to worry about the default values in there.
Is there a way in ES6 if there's to specify a default for every parameter beyond the 2, for example? So
Beyond the ones like
somebody passed in 5 parameters and you wanted like the last 3, you know, just to be like -1 or something like that. Or whatever.
I don't think so.
Okay.
Actually there is, but I'm probably not gonna. Yeah, you could put together something that does that, because this is advanced here, so you guys probably don't need to worry too much about this.
Sorry.
There's and I don't know if it's built into the language of Node and stuff yet, but there's something known as like a REST parameter, and so you could do something like you can do some really complex things like you can. Here I'm going to just, this is a much more advanced way to do it. If you guys try and work this assignment where you add stuff, but you could do something like this. Add args. I think this will work. I could be wrong. And then what that should have done, let's see what happens here. I'm not actually going to add them here, but what that should do, I think, is it's essentially spreading all of the arguments into this array. So you can put them somewhere, like you can say, take everything after this, the ones that I've named. So if instead I change this and I was like, I want the first 2 to be named, I could say like arg1 and arg2. And then I could say like other args or something. And those all end up in an array. And then from there, you could do some default stuff where it's like all these are default, and you could set something up to do that, but it wouldn't be, I don't know if I've encountered it, so it'd take me a little while to figure out how to write that syntax myself. So don't you guys go cheating and steal my stuff. No. That's why I didn't write the body. I didn't solve it for you. Any questions about sort of optional parameters, defaults? For this old way of setting default parameters, or the sort of newer way where it's right in the function declaration? Newer? You think it's easier, right? Yeah. So as long as you're in an environment that supports it, feel free to write stuff that way. And a lot of code examples you'll run across nowadays will have that. All the modern browsers, except for anything newer than IE 11, should probably have support for this type of code. IE 11 wouldn't, and I think Edge does, but I'm not 100% sure. But there are also tools to convert this code, so you get to write it this way and then convert it to something that older browsers can work with, so that you don't have to write with the older syntax all the time. Want to take a break, or are we feeling good? All right. So I talked about arity. That's that idea of how many arguments something has, which you can get through arguments.length. This is just an example of you could, if you wanted to, inside of your function, put something that explicitly says like this requires 2 arguments by checking that arguments.length thing. So if we wanted to write our add function and always force somebody to pass in 2 arguments, well, we can write that out that way against how many arguments they passed in. Yeah.
So what is, when it's writing throw new?
Throw new.
Throw new, like throw is, what is throw? Like, is that a variable? Sit on JavaScript.
I'll talk about that a little bit. I'm not gonna. I don't know if we're going to really go into too much detail on throwing errors, but there's a section, I think, like right here. Yeah, it comes up in a minute. Exception handling. So I don't think we ever talked about this. Anybody remember? Did we talk about throwing errors at all in the? We did.
Yeah, we did.
Okay. I mean, a basic review is when you're writing code and you have a problem, or you're concerned that there might be a problem, and you don't really, your code can't handle it. It can't resolve it. It can't fix that problem right there. It's like a fundamental problem to, or that bit of code. There's nothing I can do to resolve this. And I need to tell somebody that, whoever called me, so that they know that, like, I'm broken and you need to not trust what's coming out of me. You need to do something with my brokenness, whatever. That's the idea of throwing an error. So you're basically just saying, something went really wrong and I don't know what to do. And now I'm just telling you that something's wrong. Maybe you want to tell the user that something's broken. Maybe you want to do something to fix it. I'm not sure. That's really what happens when you throw an error. So you can do it anywhere. Throw new error and just create whatever error you want. My own error. And you can see it sort of throwing an error right here. Throw existing errors, and there are some that are already, defined, like, not a number type things, like, or you try and convert something that isn't correct. I don't know how to get one immediately. I'm sure I could do it just by, but maybe this will give me one. Foo.bar reference error. There we go. So the code right now just told me, like, I don't know what to do with this. You tried to do something, silly you. That's all throw error is doing. And so throw is just a keyword, something special in JavaScript, like new or like function. It's just a special keyword. The thing that is a sort of function in here is error. Is an actual, like, and it's actually a constructor, hence why it's saying new error. That's how you can call a constructor. So those two combined create a new error object. And throw just tells it, throw this error, cause this
So
chaos.
throw kind of like,
Go cause some chaos, right?
Kind of works like a console log, like throw this up, write this up on the console. In a way.
Honestly don't know why that being done the way it was in programming languages. It's part of the reason that they do it is not so much a console log, but it's a way to, it's almost an external, a separate pathway, so that when an error has happened, instead of you having to handle it as a return code from every function and work with it like all the way up a stack, you can say, like, here is an error, and let's say you like calls deep into something. Each one of those may not care about that error, but something all the way up at the beginning might. And so when you throw an error, it's a way of being able to communicate something until somebody cares about it. It's like, I'm throwing this up, and until somebody cares about it, just keep sending this up the stack and ignoring anything else going on. So it's sort of like a way to bypass the running your code back through the stack the normal way and get right to somebody who knows what to do with that error.
Yeah, sometimes what we had were custom error handlers or exception handlers, like when your resources went really bad. So something horrendous would happen, in your application, and that's fine, but you have to clean up, because you're opening up files, or maybe databases are open, and if you just drop out, then it leaves it in a really bad state. So there's an opportunity to clean things up. That's like one example of what you can do there.
And the way that you sort of handle that, and this I don't think we really talked about too much, is try catch. Did we cover try catching an error at all? Oh, it doesn't sound familiar. Okay. So I talked about throwing them, right, or seeing them. Try catch, I said until somebody cares about it and tries to handle it. That's what a try catch block does. So try means try and do something, essentially. It's like, try and do something. So here we'll do what just broke, right? Foo.bar. We know that's going to break. And then we can write the catch block. But you can also be very specific. You can be generic and just say catch any error of any kind and do something. But you can also be very specific. So in this case, let's say we're only looking for, I think the right way to do this is just reference error. We're only trying to catch a reference error and now do this when that happens. Now maybe we'll say like console.log. You tried to reference a method on a non-existent object. Like we didn't create foo as an object. You can see that this time when it actually ran that code, which is what happened when it finished all that, instead of us seeing this big, ugly reference error message, it ran our catch block and did something with the error itself. Instead, it gave us this console log, right? And so maybe in that case, instead, we didn't want a console log. We wanted to fix it somehow, or, oh, let's create the object now. You know, you could do something like that. But much more likely, you're not really going to try and fix your code in a catch block. You're just trying to clean like you said, clean something up. You know, don't let other problems and side effects lay around as a result of this. Clean everything up and then restart and try again or something. So that's the way you can catch errors and write stuff around error handling. I don't write very many try catch blocks in most of my code. I mean, something that you usually only write it if you're doing something that has the risk of having an error.
Database.
Yeah, if you're making a call to something that may throw unexpected errors, then you might put it in a try catch block so that you have some sort of path to deal with it. Like, yeah, I'm calling to a database and I don't have control of that database. So something might go wrong and I still want to keep working, or I want to clean up my connection to that database if something goes wrong, right? But if it's code you've written, well, you shouldn't be throwing errors generally, you know. Any questions about that? So I'm going to step back up here. I'm going to hide how this works, but I mentioned arguments are array-like, the special arguments variable to a function. So don't think of them as an array. It doesn't quite have all the other methods that are on an array. Like, it doesn't have for each. And there's some other aspects of it that don't really work. So you can treat them like an array in terms of having a length and being able to access the individual arguments, but a lot of the other stuff you can't. And here they have a nice simple one-line function that converts arguments into an array. And I can't explain to you how it works right now. There's a lot of complex, weird magic going on inside of this. If people want a more in-depth explanation of that line of code, I can give it a little later. It's probably a good example of things and how they interact, but it's not something I probably need to get into right now for everybody. It's one of those things. It's more like just do the magic. Just let it work its magic. If you need this, use the magic and don't try and think about all of the things going on when you do this. What?
They're just showing off.
Yeah, I mean, the funny part is this looks simple, but I'm not kidding. There are like Stack Overflow like questions around stuff like this, and a lot of people get the explanation wrong. We're like, know the language, explaining how this call or things like that work. They just get it wrong because there's a lot of interesting stuff going on. I mean, it is useful to know how to do it, but critical. Strict mode, we're going to skip over that entirely. Strict mode is just something you can set at the top of JavaScript files to say use a more restrictive version of the language and don't allow certain things that can cause problems. If you are writing React code with ES6 syntax and using modules in the first place, your code is already in strict mode. And you're probably not going to run into the things that strict mode would cause an issue with anyways. It's things like eval. Eval is evil. So don't do that. All right, variables, scoping, and closures. So this is some of the stuff that we talked about in last class as well. Again, we won't talk about hoisting. Jump right down to the scope of variables. We may talk a little bit about hoisting for variables because it's less confusing than hoisting for functions. But we'll talk about the scope. Do people remember what scope means when you're talking about anything in JavaScript or any programming language? Give me a definition of scope.
It says is it always the function.
So this, let me try this. So everything that is inside, or in this case, inside that function is scoped only in that function. So if you try to call bar, if you try to console log x, it won't exist outside of that function. Only exists when you run that function.
Yeah, I think you're explaining it well, and you've got the concept. I hope this will make sense, but in the shortest definition of scope, scope is the code that a variable is accessible in, essentially, or a function or something is accessible in. Where is it accessible? Where can I access this function? So for example, they said variables are function scoped here. Again, being lazy, I'll copy this so I don't have to type it out. Oh, I don't know if it worked.
Maybe because you have those triple dots.
Do I need another? Do I need another one? No, it may not. It may not let me. All right. Oh, I know why. Silly me, because I didn't actually call it. Foo is not defined. I just defined foo up there. What do you mean?
But you never returned, so it wasn't ever really.
All right, I'm just gonna write it out then. So we'll write this out. Bar x equals negative 512. If x is less than 0, then because there's dots in the middle of it. They assign a temporary variable. Var temp equals negative x or negative x. X equals temp, I think. So that x is now, some new value. Blah, blah, blah. Whatever else you want to do. And then they did console.log temp here, right? If we call foo, what we get out is 512. And to some people who are familiar with other languages, that may be a little confusing. But the idea here is that temp is scoped inside of this function. So anything inside of that function has access to that TMP, that temp variable, because that's the scope of it. Some languages, and in fact JavaScript does have this, have what's known as block scope instead. Confuse somebody who's familiar with other languages, because we defined temp inside of this if block, right? And so in a lot of languages, temp would not be accessible here because its scope is just the if block. So the minute you're outside of that if block, it doesn't exist. It's not accessible. In JavaScript, by default, it is accessible. Now, the hoisting portion of that, so if we rewrite this a little bit, we're going to do var x equals -512. Oops. Just write the same thing. I'm going to do console.log tmp. Is anything already begin to look weird to somebody right now? If it does, speak up. What do you think looks weird so far?
You got temp and flow.
But I haven't even created temp, right?
Yeah.
Out of that. It's console.log temp. Let's close this. So now let's call foo. What do we think the results are going to be for this? Any guesses?
Undefined. Or an error.
An error. Undefined. What? 512. Huh?
I was gonna say 512.
So the output is undefined and then 512. And what's going on is it's running the code. It runs the code sequentially, right? For the most part. This is the magic of hoisting. So at the point where it does var x, okay, we did the variable x and we've assigned it a value. Here we log temp, but we haven't defined it or anything yet, right? So why aren't we getting null, or why aren't we throwing an error because we're trying to access something that doesn't exist? The concept of hoisting is when you're creating variables using var in JavaScript, we could rewrite this function declaration this way and it would really be the same thing. So this is what hoisting is in JavaScript. And it's useful to know because you will encounter it or run into problems with it at some point. So you could say var x equals -512, var tmp console.log tmp temp if x is less than 0, right? tmp equals -x console.log tmp. So if you notice, the only thing that's really different here is I added an additional var at this line right here, right? For tmp. That's what's known as variable hoisting. So if we run this now, we should see the same results. Implicitly happening when it sees this version of the function. In JavaScript, before it runs through any of the actual expressions here, it looks for any of these var declarations and essentially moves up to the top of the function the declaration of that variable, but not the assignment, because it can't do that until it reaches that point in code.
So the reason why it's positive is because it's like,
Yeah.
okay.
Yeah. Maybe that was too tricky. Could have made a simpler version, but does that hoisting make sense? A little confusing as to maybe there's not like why. Nobody's like why? Why does it do that? Honestly, don't know. And you'll run into, as I said, some of the newer ES6 syntax doesn't do that. So instead, you're declaring variables using let or const, which will run across. Those don't hoist at all. So if you want to see that, I could show an example of that, or we can sort of keep moving through this. Let's see, they pretty much wrote the same thing. So closures, talking more on scope, right? The idea of what the scope of a variable is and what has access to it. I think this is just slightly confusing, so I'm going to change it just a little bit instead, but it won't be much. Create incrementer starting value And then I'm going to assign a variable here, which will be current value equals starting value. And now from this, we're going to return a function. And what this function is going to do is increment the current value and then return the current value. This code's just, I mean, it's slightly trickier than the stuff that we're used to, but definitely within the realm of what we're going to have to get comfortable with for this class. What we're doing is creating a function that returns a function inside of it. So that means that if we look at, like they did, increment equals create incrementer, and we'll start with the value of 3. If we look at inc, what it says is this has a function right now because that's what we returned, right? And how do you call a function? You add parentheses, right? So we can call this as a function because that it's just like any other function. Except it's doing something that's a little magic. And that each time we call it, it's returning a different value.
Incrementing by 1 on the plus plus.
Because I'm incrementing by 1. But this has to do with the magic of closures and scope, right? Because the scope of this current value, this is in this, when we're inside of this anonymous function here that doesn't have a name, this is still in scope for that, right? It has access to it because it's in the scope. We haven't exited out of that whole function, outer function. So it has access to that value. And then that means when we return this function, each time this is called, it still has access to this variable inside of him. And he can increment and change it. But is there anything else in our code? Is there any other way our code could access this and change it now? Or is it sort of protected? Is it like if we wanted to get access to the current value with some other way, is there any other way to get access to it that you can think of at this point? What?
Can't you put in a loop and just have it keep doing it?
We could have here, yeah, but if what I'm saying is now that we're at this point in the code, could we get access to this variable any way other than what's getting from our increment? Oh, let's try it. Not defined.
Is this something you can access through inc?
Sort of the magic here is there's really no other way. What we've done here is current value exists, but we can't access it in the outer scope because remember, it only exists inside of this function, right? And this function we returned, which still has access to it, and can manipulate it, but nothing in the rest of the program has access to that variable anymore.
So the only way to get it is to call the function.
Is to call the function. That's the only thing that we have that has access to it right now. This is what's known as a closure. So what we've done is we've closed over this variable with this internal thing. It's a little bit of an interesting pattern. This still exists and can still be changed and worked with from here, but nothing else has access to it. We've sort of hidden it. We've closed it and said, here's the only way to access this item, and it can still manipulate it and change it. But it let us write a really cool, I mean, I don't know about you, but I think it's really cool. It let us write a function that every time we call it can return a different value, even though we're calling the same function. On the outside, it would be very hard to understand why that's going on. You sort of have to understand this internal variable being held onto in the closure, but it's a pretty nifty little bit of code. So who's confused by this? No? There's not enough people confused by this. because I still have some confusion over this sometimes. It's something that's not unique to JavaScript, but definitely much more popular in JavaScript than other programming languages. The idea of working with a closure.
Will you come across closures often?
Yes. You probably come across them more than you would think by accident. So it's very important to know how they work, because if you misunderstand how some other code works, that's where I guess you'll make mistakes more. I'm trying to think of a prime example of this. I have one literally written down. I give it as an example to some people when I'm trying to have them explain closures to me, but I'd need my own reference for the example. But you'll commonly encounter it where you expect one value to come back. Value, like maybe you iterated through an array or something in somewhere, and you think you should be spitting out each value from that array. But in reality, what you're spitting out is the result, the end value of the array, like every time, because you didn't actually call it at each point in time. You called it at the end, and it just keeps giving you the last result from iterating through it. You probably run into it much more, at least at first, by accident, where you're like, I don't understand why this value isn't what I expect it to be. Why isn't it spitting out every one of my values the way I want? So I think they have a much shorter explanation of it. A closure is a function plus the connection to the variables and its surrounding scopes. So are there any questions about that right now? I'm sure there'll be more later on. We'll continue to work with that. I'm going to skip the iffy pattern. It's not as common now because we have proper modules in ES6, and I'd rather you just learn how to work with proper modules than learn the complexity of the iffy. If you guys want to, I'll send this stuff out as a link. I actually will this time, I promise. Then you guys can look over this and try to understand it a little more. But it was a very common pattern in JavaScript as a way to create and stuff like that. So let's take the rest of the class and we're going to review objects. So we've already talked about this at some level, so I'm not going to probably spend too much time on this basic declaration, but remember, objects are just really, in JavaScript, the best way to think of an object is just a collection of key value pairs. The key is the property name, the value is whatever it has in it, and the values can be anything that's a valid JavaScript value. So the values can be functions or strings or numbers or arrays or objects. The simplest way to create an object is just using the object literal syntax. So Jane, and they just create like var Jane equals, and you just start with object literal syntax right off the bat. So then you can say name. Object literal syntax is just key followed by the value. The key is name and the value is the string Jane here. And then in this one, the key is describe and the value is what? Value is a function, because a function is a valid value just like anything else. Function, return person named plus this dot name. And does anybody remember what this does when you're inside of an object?
Refers to itself.
What?
Refers to itself.
Refers to itself. I like that. Short, simple thing. This refers to itself. So if we were outside of this, we want to get the name of Jane. How would we get Jane's name? Jane.name, right? But when you're inside of the object, when you're on a function that's inside of your object, you don't know that the variable name is Jane. All I know is I've got this anonymous object. How can I refer to properties of it? That's what this lets you do. It lets you refer to the object, your own object, and work with it.
So is that the same thing, or is it different from like I guess city brackets and stuff?
Oh, that's just all that is a shorthand. Yeah, I can rewrite this. So let me rewrite it slightly so that
So on the
it's closer to what you guys are used to for string literal syntax. So name Jane.
so the describe property, is that creating a new scope as well?
What's that?
The describe property. Is that creating a new scope when you write function?
Yes, there is a new scope inside of that describe property. So if we had a variable inside of this function, it would only exist within that scope, the scope of that function, and not outside of it. So this is just the string literal syntax, and this is part of ES6, although we did use it in class. So if we still wanted to get access to the name in here, we would still do this dot name. The other version was just using string concatenation. So plus was just concatenating this string with whatever this came back from evaluating this. So now it should still work the same. Jane dot describe person named Jane. So yeah, it's just two different ways of doing string creation. This one's this string template or string literal syntax is a nice ES6 feature. It lets you not have to write a whole bunch of pluses a lot of times, stuff like that. So far on object literal syntax, yes.
So why do you have to use this? So like in the other, on the previous example, you had a return a function as well, but you knew that that variable was outside of its code. You remember what you were saying?
Yes.
Okay, so in this, it seems similar because it should know that name is there. Why do we have to use that name? If you,
Yeah, that's a good question. So it's a little confusing probably because it uses the bracket notation as well for objects, for object creation. But the key is themselves don't create a scope for the object, and properties of that object aren't in like a scope in a sense. So if I have, let's create another one, and I'm not even going to assign it anything. We'll just John, and then we'll have a describe. I guess I better assign it. I'm gonna have to. Let me do this. Roles. Use this. We have an object, and it's got a function and a name. If we call John.describe, what we get back is name is not defined. And that's because an object itself doesn't create a scope. So the fact that this is all an object doesn't mean that this describe function has access to this property name of the object directly. So it can't access that name of the object, which how do you access the name of that? How do I access stuff on the object that I'm inside of? What is some mechanism to give me that access? And that's what this does. because this is actually, it's part of that scope in a sense for it. This is in the scope of the object and gives you access, whereas directly in some sort of scope.
That makes sense. And yeah, I think definitely the brackets makes it look.
It makes it look like you're creating a scope. Yeah, but you're not. That's a good point. There's only so many common delimiters, ways to split stuff up, right? And so programming languages tend to reuse them in different contexts that aren't necessarily the exact same thing. The confusion over thinking that they're the same thing. So any questions on object literal syntax, creating an object that way? No? You feel comfortable with this generally and using this to refer to properties on the object when you're inside a method on the object? Yeah. So another thing, we didn't really go over this too much and we probably won't use it, so I'll just gloss over this real fast, is you can actually check and see whether a property exists on an object. Because remember, if we did, this operates like arrays or like the arguments. If I check for a property that's not there, I just get back undefined. It doesn't tell me this property isn't there. If instead I did Jane.foo equals undefined, well, Jane actually has a foo property now, but it's still is undefined, right? It's not clear. You can check with using the in operator where it actually exists. So you could do like name in Jane, and it's going to tell you that actually exists on this object. And I think foo in Jane should tell me the same thing now because it's actually a property there. It just has the value undefined. But bar in Jane, it's false because there's no property there. Like I say, it's not something that we'll really dig into too much. But you can use it if you actually need to check if that property exists on it or if it's just undefined because it doesn't exist or they assigned it to undefined. Might end up using is delete. So if you want to actually remove a property, you can use delete to get rid of it. So we can say delete Jane.foo. And now if we look at Jane, or a foo property anymore, and if we rerun our code here, foo in Jane, it's false. That property's been completely removed. So that's a useful thing if you're manipulating an object. You want to get rid of some properties because they no longer belong on it or shouldn't be on there in the first place. Any questions on that? That's pretty straightforward for the most part. So the other thing you need to be aware of when you're working with JavaScript objects is your keys, right? We had name, right? Jane.name. It can really be pretty much or almost anything. Only certain keys can be done without sort of this quote syntax. So ones that are safe to use, like name or other strings that are sort of safe. But you can add pretty much any key. So their example here we'll add something crazy to Jane, and you can use bracket notation as a way to do some of this. But foobar, huh? So then you can access the property, like Jane has a foobar property now, which even has a space in it, which isn't a valid variable name. And you wouldn't have actually even been able to do that using the object literal syntax if you just had it without quotes around it. But you'll notice when it outputs our object here, it puts quotes around it even here, right? And that's the way you can use bits you wouldn't be able to use otherwise is quoting around them, or also using this bracket notation is the other way to access keys. So you could do Jane name and see the value of it. And the value of this, we've talked about this bracket notation in class, but one of the values of being able to use this bracket notation works for programming much more powerfully than the dot notation, because you can't put a variable name in dot notation, but you can using bracket notation. So if we want to get the name, we could say like var get name equals name. And the get name variable is, right? And if we wanted to get the name off of Jane, we couldn't write Jane.get name, because that's undefined. There's no get name property on Jane, it doesn't exist. But we could do Jane get name and get the value of the name back out, because when it evaluates this whole expression, first it looks inside of these brackets, says, oh, this is a variable name. Let me replace that with the value, the string name, and now I know how to evaluate for the key name and give you back the value. So that's something that you can do. Like, you end up using that bracket notation most of the time when you're doing very programmatic property access, because you might pass in a variable telling it what property to read, and you wouldn't be able to do that using dot notation, but you can using bracket notation. This is a lot of information we're throwing at you today. So a lot of it, I mean, a good chunk of it's review, but some of it is sort of new bits woven in. So I hope that a lot of it you're feeling like, oh, I'm sort of comfortable with that. I remember that. Oh, this was challenging. That's new and challenging. And we'll retouch a lot of this stuff over time. I'm not going to go over this idea of extracting methods. We'll cover this when you guys start running into problems with it. But it has to do with the fact that this doesn't always work the way that you would expect with functions in JavaScript. It's a little tricky, and when you guys start running into problems with it, or we cover it in the React documentation, that's when we'll get into that, so that we're not adding another deep, confusing concept to you immediately. I think I'm going to cover constructors a little bit, and I feel like we're comfortable with arrays. We don't even have to talk too much about them. But I'll cover constructors as sort of the way to create multiple objects. It should be a review again, and then we'll be done with this review. And again, I'll send out this link, as well as a link to a lot of this ES6 syntax, newer style of JavaScript. And then for the homework, it'll pretty much be try and work through this HTML5 and CSS, and I'll give you the one that I'd like to see people work through. Because in the next class, instead of me talking, I'd like to have a conversation about what you had issues with, the challenges, your confusion around HTML and CSS and stuff like that. But constructors, the last little bit, constructors, factories for objects. So this is just another way to create objects. We just did object literal syntax. But if we want to create multiple of the same type of object, the way you do that, or the traditional way to do that, is using an object constructor. It's just a special type of function, or a function called in a special way. So in this case, point, like we're plotting a point somewhere, x, y, and you can say this dot x equals x, and this dot y equals y. And now if we want to create points, like point objects, we can just say like point 1 equals new point. And this one's at 1, 1. So point 1 is an object of type point, and it has the two properties that come from a point. So that's how you can create an object constructor. You can just do this dot, use the properties for your object, and then you get that back. And so we can have a point too. And how do we create an object or point object? new point. We can make this one at, I don't know, 5, 5 or something. So now I have a couple different point objects. And they both, it was very easy using this object constructor syntax to create objects of the same type. And now we can, this is where JavaScript is sort of cool. I'm going to do something magical here that, you know, a lot of other languages don't necessarily support. We want to be able to do some stuff with a point. Like, let's add this distance function. How far away are these points? We'll add this same one. And what you can do is add something to the prototype, which is saying like the source of these objects, the object that these objects sort of come from. And let's add a distance. Let's call it distance. I think that's what this is. Function to it will return math.square root of this dot x times this dot x plus this dot y times this dot y. And now, oh, I don't have a point, do I? I have a point 1. If we look at point 1, we didn't add anything to point 1. But now every point on its prototype, which means that it's sort of inherited in their inheritance chain, they now have a distance method. Every time. And point 2 has it as well. So we added a method to the prototype for these objects, and now they have access to that method and can call it. But one of the magical parts about JavaScript there was we added that prototype after we created the objects. We added that method to the prototype later, and they still exist on it. So you can add it to your prototype at any time, and any object that has that prototype method is something that it's able to act on and work with. I think the prototype part probably not as critical for you to have picked up immediately from that, but definitely the idea of having some sort of factory to create objects, sort of important out of that. Is there any questions about any of this? What was the hardest concept today for people? The one that maybe you didn't get the most, and the one that, like, man, that was completely confusing. Nothing?
It's confusing, but I think the homework assignment will help understand arguing arguments, or using arguments, and being able to use that.
Arguments. I will, you know what, it'll be optional, but I'll just, some people weren't in the last class. I'll add an assignment for that from the last class, and I'll add other people onto that. It was a site that I used for homework that allowed sort of automated testing, but I'll add one for the ad, at least, that can take any number of arguments. And that way people can implement it inside of there.
And say if they're close.
Well, I mean, you can implement your code in there, and I'll have testing against it to test a whole bunch of different routes to see what happens, and see if it's the expected outcome. That way, and like I say, people don't have to do that, but they want to work through that. If you have other topics, by the way, I'm not really clear on that. That one was hard for me to understand. Let me know. Like, send a message in Slack, and we can see if we can go over it again, or I can create some assignments around it to try and make it give you a chance to work through it a few more times to pick it up, or anything.
I mean, I get it when you explain it, but I feel like using it, I would confuse myself with this reference where it like references itself and the function inside of a function. because there was like two ways you showed it, but it was, I don't know. Like, I kind of got confused the difference between both of them.
Right. And both of those are really good ones to begin to understand because those will be patterns that we'll see a lot in the React code. So I'll definitely make sure I go over that again and maybe try and create some assignments or something to have you guys work through them a little more.
The function scope.
Function scope.
Yeah.
Or variable scope inside of functions and stuff. Yeah, the closure I don't know if I'll create something about a closure right now. That's something that'll probably just be better working through several more times before I have you guys try and tackle creating your own closures and stuff. But in terms of when something exists in a function, I may be able to, I don't know. It's a tough one to create a specific assignment for. We can think about it.
It'd be a good one maybe
Let's see.
to put out like a incorrect version and make it, you know,
Ah,
to actually correct it.
yes. That's smart. Yes, I love that. Yeah, I like that. That's good thinking.
Debugging. Forced debugging.
Right, forced debugging. I haven't done assignments like that. I should do some. That's a good idea. Flip some more of them where it's like there's a bug in this. You have to find it and solve it. That's cruel. I like it. Anything else? Awesome. Well, like I said, I'll send out. In fact, I'll probably be posting it right now or right after class. Whoa, it's so tiny now. This homework assignment to work on the HTML and CSS. That's probably the most pressing thing to try and work through for the next class so that we won't have just a lecture. It'll be more of a conversation, talking through challenging issues and stuff like that. Next class.
How far do you want us to go?
I'll reference it exactly, but SAS.
Yeah.
If you want to talk about it, I can talk about it a little bit. When we talk about CSS, but really all it is a way to make CSS easier, because CSS can be repetitive and it's not easy to share things like common color between different areas, and so SAS lets you do a lot of that much more easily. They are. There's also, if you, for private restroom or something, there's one back in that direction over there, sort of behind all the. Yeah. Oh yeah, if I could have a couple people at least stay around and help me move this table back too. Like Rondell.
Gotcha.
Like you.
Okay. Yeah, okay.
Big, strong people.
Before we do that. Some difficult
That was a nice way of saying I'm volunteering you to volunteer.
Jared, when I try to write this, I don't know how to navigate like to what is on Node.js. Like to have that return, you know, on Node.js like this.
Oh, okay.
How do you do that?
The first
Yeah.
one. Go back here for a minute. This is probably partially just language, but when you're missing the C in function,
Oh, yeah, yeah.
then it's not going to give you the sort of dot dot dot. But you don't have to write the dot dot dot. Those are that's just
Okay.
essentially what that is just
Oh,
node telling you like you're inside of something right now,
Mm-hmm.
and so it's saying, oh, you're inside of this function. No visual indication, like you're
Oh.
you can move it. It should be about
That's too
right.
Too much. That's too much.
This is right.
About, yeah.
I think it's about right.
Okay.
Yeah, so it's just like a visual cue saying you're inside of the function still. So you can see it'll just keep doing that. And then once we put the closing bracket,
Mhm.
it's like, oh, you're out of it.
Okay.
Yeah.
Thank you.
Yeah, no problem. That's a good question. The first time you encounter that, you're like, why is it doing this? What's going on? That's really weird.
Thanks, Sharon.
Yeah.
Next Tuesday, I should be okay. I might be in Chicago. Won't be here next Tuesday. We'll see.
Okay.
I'll find out in 2 days.
Well, not. Will you be here the Saturday after that?
Yeah.
Probably. I've got a race that Saturday.
Oh, okay.
So if you can
You want me to cover one?
class, yeah,
Holy cow. Yeah.
you got it. Listen, you're better than me. You already knew how to write this
No,
other thing.
I don't. Especially not on the React stuff. So I'm learning about these guys on that. But anything you want me to do, I'll be happy to.
Yeah,
So,
I mean, honestly,
Especially if it's like more like interactive debugging kind of stuff, then that would be good too.
a lot of that will probably be at that point because that'll be the goal will be HTML and CSS next class, and then we start with React on Tuesday. But I suspect Tuesday and next Saturday will still be a lot of getting people some
Yeah.
running.
Right.
Whose stuff isn't working yet.
Yeah.
There'll probably still be a lot of that type of hands-on debugging.
Cool. Yeah, sounds good. I'll be happy to.
Awesome.
Yeah.
Yeah, I would like to ask you another question. I would like to know if
Oh.
I can use your name. I don't know your profile for.
Just a moment. I forgot to stop. How do I can't get to my other window of it. How do I stop my live event? I had a Hangout running. Where did it go? All right, hold on. Where's my other? Oh no! I don't know how to get to it. Is that took over? Oh, wait, control. How do I show it? How do I hide it? Oh, maybe that's not the right one. There we go.